Yes, so we are live to go here on February 23rd, the Columbia Basin Geologic Society and Eastern Washington University Geology, soon to be Geosciences Department coming up. Happy enough to have everybody's favorite biologist here who can bridge the gap. But before we go there, I want to mention real quick that I'm the president of the Columbia Basin and the chair of the Geology Department. So if you would like to be put on the email list, please feel free to email C. Pritchard or Chad Pritchard at EWU. I'm happy to add your name to that list. If you are getting emails and you're annoyed, please let me know and I can take your name off that list too. I hear through the grapevine that on March 18th, John Riedel from the National Park Service, a geologist that monitors glaciers, is going to give a talk on the status of glaciers in Washington. And that's going to be given through the Ice Age Flood Institute in the Palouse Falls chapter. So if you go on the Ice Age Flood website, you can join on that for March 18th. And then our next talk for the Columbia Basin will be the wonderful Dr. Erica Rader from University of Idaho, who is going to talk about basalt and mixing basalt and playing with basalt and how that affects what they think is happening on Mars, which is kind of timely, seeing as our Mars exploration is there. So without further ado, I would like to introduce the Dean of the Doctors, as I know him. Always a person I enjoy chatting with about how much he's engaged students and published a paper with one of my favorite students and has done amazing things at Eastern Washington University. And we're lucky enough tonight to have him talk about his research up in northern Idaho on early Pleistocene mammalian fossils. So here you are, Dr. Case. Thank you very much.
All right. Thanks, Chad. I appreciate it. So this is relatively new. This whole project is literally just a little over a year old, and it's centered from some students that you're going to see here in the next slide. But when we talk about mammalian faunas sort of throughout the Cenozoic, this time of the early Pleistocene is really interesting because we're sort of going from animals that aren't present around today to getting very close to those that are. So it's an interesting transition period where we see a lot of genera of animals, that sort of taxonomic level, being originated around this time at the beginning of the Pleistocene, and then we see their descendants around today. So it is an interesting time that we have. Okay, so the people that I want to introduce you to are all of my students. The three here that you see sort of in a row, Jonathan Welch, Marlena Blua, and Neville Magone, were students that took on a particular project based on some material that Jonathan was bringing in. He lives in the town of Priest River up in the Panhandle. And he had been out sort of looking at some areas around the river during different times and had come in to me before Christmas more than a year ago with a variety of bones and say, hey, are any of these fossils? And he was going to be in my class the next winter quarter, so come January, on a capstone that I do on vertebrate paleobiology and macroevolution. And so we were going to be doing a lot more with fossils there, but he was curious. And most of what he had were just sort of old bones, a lot of old deer stuff is from carcasses people had thrown away. But there was amongst that some bone that was in fact fossil bones. So I said, yeah, so wherever you might have been picking it up, look around and see if you can find any more. And then about a week or so into the course, he and Marlena came by, and he said, I was out collecting, and this is what I came up with. And now he actually had started to have some specimens there. So I said, hey, this would be a good thing for you guys to take on as your class project in the second half of the course, to begin to identify who's there, what's there, and then we can start figuring out the exact age of these particular fossils. Okay, so that's this group. And so they made a presentation at the end of that particular course to their fellow classmates in the spring. Marlena headed up the poster presentation in presenting it at our research symposium that we have in May. And then all of them were part, along with myself, part on an abstract and a poster presentation in this past October to the Society of Vertebrate Paleontology. So this has gone out to some degree in a virtual conference about this research that I'm relaying to you. Okay, and then Ashley down here. Ashley is a student of mine who was doing research on felid prey acquisition. And one of the things of comparison and comparing what cats can do, we were also comparing what canids can do. And she helped me gather a lot of data that we needed on the canid we have from this fauna, because in order to get sort of the exact size of this particular lower molar. So she had a great deal to help with that part of the project. And the last person to sort of give kudos here, that's the only sort of suite of people that have been involved in this project, is my wife, Jean, who's formerly a geologist within the department where Chad is. And she came out to evaluate the geology and check on my stratigraphy, make sure that all of my interpretations were correct around a couple of the sites. So anyway, this is the group that's been involved in the project. So originally in the suite of animals that Jonathan and Marlena had presented me, were a variety of teeth, or in one case from the muskrat, a jaw, and now we have some other material. And in a couple weeks, a week from Saturday, I'll be going up and meeting Jonathan up at the site again. And he's found a couple of new things, including some new jaws as well. And we'll take a look at a new site that he's found. Okay. And so originally we had a bear that you'll see some of the representation, lynx, you'll see some of that. And then there was the muskrat, beaver, and deer. And Jonathan started the initial work describing the muskrat, Marlena the beaver, and then Neville the deer. And so those were the contributions they made to the initial poster that was there. Okay, so this was our suite of animals. Subsequently, then, I had gone up several times with Jonathan to look at some of these sites and to make sure that where the fossils exactly were coming out from. And we've clearly identified sort of the unit that they're coming out from. We'll talk a little about that towards the end of the talk, okay? And we've come up to some other suite of new animals that we didn't have before. We now have a porcupine, a species of canid, so some sort of coyote to jackal kind of early member of the genus Canis. We have a type of actually dwarf pronghorn antelope, and we have a horse. So we've got 3 herbivores, we've got 3 carnivores, and we have 3 rodents. All are giving us some interesting parts to the story in order to try to figure out exactly how old this fauna may be, because this is coming out of a clay deposit and it's not going to give us anything to do any kind of radiometric dating, and the data that we have from any previous mapping just indicates that we're in some Pleistocene deposits. That could be early, that could be middle, that could be late. And that's sort of all the information we have to go on before we began this particular taxonomic study to try to figure out who's there, and from then who's there, when have all these animals, when can they have all occurred together? Okay, so that's really where the whole project was going. So we're really concerned about this question is, what is the age of the fauna? And that's what we'll get to at the end once we've seen the information that we can gather from any of these particular animals. All right, so one of the things that when we talk about time is that you've got the standard kind of units you're familiar with, and that's sort of these ones over here. So things like Miocene, Pliocene, Pleistocene, Holocene, okay? But for those of us that deal with fossil mammals, especially here in North America, there's another time scale we go by, one that originally was trying to finer subdivide the Cenozoic epochs into a series of well-known faunas from classic localities throughout the United States or elsewhere in North America, some from Mexico, some from southern Canada, places like this. Okay. And so in 1941, a group got together called the Wood Committee to try to construct what is called the North American land mammal ages. And that's the names series that you see in this particular column. And this, like originally our geological time scale, was a relative time scale in that we knew one group of fossils was either older or younger than another group of fossils that we have coming from some of these classic localities, and each of the names comes from that sort of real classic locality somewhere, generally within the United States. Okay, so like the Hemphillian, the location is the Hemphill location, that particular quarry, and the sort of adding an onto the end to create the name. Okay, so we were really concerned about things in this sort of time frame because that's the time frame that we have for other kinds of faunas within our region that we'll get to here in a moment. So since creating this whole series beginning in the 1940s, 1950s, and then through the 1960s, then all the task became to say, well, we have these units, just like geological units are there originally as relative, one older than the next. And where they've been trying to add dates to the beginning and ends, that's been a major emphasis for people associated with mammalian paleontology, is to try to know what the boundaries of each of these land mammal ages are. So lots of work has been going on to looking at paleomag stratigraphy, absolute dating stratigraphy, chronostratigraphy within this, trying to figure out what these actual boundaries are as far as time. Okay. So time, since that's our major question, we would like to know to which of these sort of late Cenozoic land mammal ages this probably belongs to, given the suite of animals we're already introduced to. Okay, so we're focused mostly on this North American land mammal age because of the Blancan. We have kind of focused on that because the other faunas that are regionally closest to us all fit in this particular time frame. Okay, and so that's where we focused on first, and where we're making our comparisons to in order to figure out where does this new Priest River local fauna, where does it fit into this sort of grand scheme? Okay, so for the Blancan, it continues to be sort of divided in two ways, either early, sort of middle and late, or medial, since we're talking about animals and not rocks. Or into a series of 5 numbered units. And it's sort of gone back and forth of who follows what system. But we're sort of looking at one of these two systems, and we've got good brackets sort of when each of these particular timeframes exist. Okay, so we're pretty sure on the duration of any of these, which means that would help sort of plug in once we come to some decision on who we have and what that means through time, where our local fauna from Priest River may sit. So we'll come back to this towards the end. Okay, so here's our site up here near the town of Priest River. And the two other sites that are really known to produce a series of faunas are one near Hanford and at White Bluffs, a series of sites there. And from the Ringgold Formation, and within there, the oldest one at the bottom of the section is White Bluffs. There's another less populated fauna as far as number of taxa called Bluffton. And then finally, the Taunton is the youngest of those. We'll put this into that time frame here in a moment in the next slide. Further away, but the other sort of area within Idaho is sites associated with the Glen Ferry Formation, these are the Hagerman sites in the Snake River Plain. And there's Hagerman itself, a real classic fossil locality. Grandview, which is sort of a series of sites sort of spread out along the river. And then the youngest of that group is the Frohman Ferry particular site that's there. All right, so we've got these 6 other local faunas that fit into more or less that Blancan time frame here. And so here are the ones from Central Washington, where they sit time-wise, and here are the ones from southwestern Idaho. And only recently has that Frohman Ferry, now that the sort of boundary here has been more confirmed, indicates that Frohman Ferry is not part of the Blancan, but actually extends and is part of the earliest part of the Irvingtonian. That's the next youngest land mammal age after the Blancan. Okay, so the question comes, where might, amongst the groups of animals that are present from each of these local faunas, where do we see, 1, the greatest resemblance, and 2, from the animals that are there, how many do we have that might be associated with any of these given faunas? Okay, so that's the sort of task we had, to look at who we had, what characteristics that we can see, to try to put a name as much as we could on those 9 animals that we had. Okay, so first one we want to talk about is the horse. Okay, so from this, we've come up with 3 major teeth, the adult upper premolar, and we have 2 deciduous teeth, one from the top and one from the bottom. Okay, all of these, since for many of the taxa, both the deciduous teeth, so that's the milk teeth that have fallen out and are rooted, versus this open-rooted type adult teeth, help us identify which particular teeth we have. Okay, and so one of the things that we're able to determine in looking at the teeth, and it was especially important looking at the adult tooth, since that's where most of the descriptions have come from, was trying to decide which horse we had. Were we already into the genus Equus, or were we still in an earlier genus prior to the radiation, origin and radiation of Equus? And we determined from looking at these areas where we have these sort of fossets, areas of dentin surrounded by enamel, that we don't have big invaginations in here, which is typical of looking at anything in the genus Equus, including modern horses. Okay, so that meant we had something that was a little less advanced. And in our local area, one of the things we had was this genus Pleistocene. And from some of those sites like Hagerman and some of the younger sites, the particular species was Idahoensis. And so when we looked at our particular adult tooth especially, and we do have some information from the upper deciduous molar, it doesn't show a huge amount of wear, and there's some characteristics to see, is that this is pretty much what we think we have. We have a species that's close to Idahoensis. We have similar morphology. It's a similar size. We'd like to have a few more adult teeth to say absolutely positive for sure. But what we do know is we have something in the genus Pleistocene, all right? We think it's Idahoensis, and anything that would be in that particular genus, one of the things is that it is early Pleistocene, it is Blancan, it doesn't go into the Irvingtonian. That's where we begin to see Equus and the radiation of Equus. So this is the one that would indicate we can be no younger than the end of the Blancan, because that's sort of when this particular genus stops. All right. So one of the observances, and this is one of the things that Neville had worked on, is so we've got a small deer, right? It's not as big as a white-tailed deer. It's more of the size of mule deer that we have. And this is Bretzia, and there's a particular taxon that's known out of that White Bluffs, the oldest one here in central Washington, Pseudosales. Okay, so we made some comparisons, and the morphology is really consistent with being in the genus Bretzia based on the kinds of things we see. We've got two different molars, one in fairly good shape, one that's really been worn down a bit by the individual that had it. And from what we can see here as far as size, this is smaller than the original one described by Gustafson in 2015. So we have a species of Bretzia, but it is below the range for the size of these two upper molars that we have here. So our species is smaller than the one that was originally described as the type species for this particular genus, right? So we know we're in the right genus. We just looks like we have a different species, and we're trying to compare it to species that occur elsewhere within the US, within that same genus, to see how well they compare. But it's been harder to look at comparative material. Where comparative material here for our local Washington one is easy because a number of that stuff is housed over in the Burke Museum. So we have access to it. Okay. So we have Bretzia, something though that's not the well-known one out of White Bluffs. Okay. One of the latest fossils that we have found are a series of one good tooth and a couple of partial teeth of what's a dwarf pronghorn antelope called Capramarics. And so when we look at the morphology, it's clear the tooth that we have a pronghorn for one, based on the size that it's tiny, so it's not the pronghorn that we have today, Antelope capra. So we've got this fossil taxon of these dwarf ones, Capramarics, and this tooth, size-wise, morphology-wise, is almost identical to that tooth out of the youngest of the Central Washington fauna from Taunton, and so this Tauntonensis. So we're very close to this. The morphology matches, the size matches. We'd like to have a couple of more teeth to thoroughly conclude that kind of decision. So we're kind of in the point of saying it looks like, that's what the CF here designates, this Tauntonensis here. But we do have this. So what does that mean? Because the youngest member of this particular species is no younger than 3 million years old. And if we have the same taxon, then it's going to be a time extension for it to the particular age that we have represented by Priest River. So that's another thing, sort of pulling it into an older time frame. So taking it a little towards the mid-Blancan rather than being something that might even be Irvingtonian. Okay. All right. This is going to be one of the hardest ones for you guys to actually see, because you need to look at the tooth from different angles to actually see all the morphology that's here. And this is our dog. This is our canid here. And one of the things we can absolutely say about this tooth is that it is in the genus Canis. So we've got some characteristics here that are identifiable, even though we're missing the front part of the tooth. And this is where Ashley Dustin had helped me because she was working on a variety of different canids at the time to add to her project. And she took a lot of measurements of basically this front part of the tooth from this notch to the front end of the tooth, and what percentage was this compared to the entire tooth length, so we could figure out how much of the tooth we were missing. And it turns out when you look at things like fox and you look at coyotes and you look at wolves and even dire wolves, that all these things run somewhere from around this anterior part going up to the periconid and the crest heading to the end of the tooth, making this sort of long shearing blade that we see in all kinds of dog-like animals here. So again, wolves, coyotes, and such. That it's about 25%. So we added that onto the length of the tooth we already had. And that put us in the size range of these three particular animals, which are some of the earliest members within the tribe of canids that include wolves, coyotes, dire wolves, things like that. So this is the beginnings of the sort of genus Canis and everything. So Euscion, Davisii, Canis ferox, and Canis theodes. Okay. Now, one thing about our specimen compared to many other canids, okay, so typical of canids, we have this long blade here, and then normally for most kinds of animals that have a sort of remnants of a triangular trigonid, hence where the term trigonid comes from, is a triangle that goes from paraconid, protoconid, metaconid, and within canids, this cusp called the metaconid itself is highly reduced so they can generate a more blade-like environment here. And that's exactly what we have. So this is a tiny, tiny cusp where this is this really big cusp, and we have this other large cusp creating this big shearing blade in the front part of the carnassial that you have, the slicing part that dogs have, okay? So we've got all of that kind of morphology, but we have something different. We have an extension off of this protoconid to have a blade-like structure here, and it's difficult to see from this angle that we have as it comes down, and part of it's been broken and some part of it's been worn a bit. But we have a blade basically continuing that shearing blade back to the cusps on the talana, the heel of the tooth back here. So it extends that shearing blade back. And very few canids had that feature, okay? So matter of fact, one of the things that we saw it in is that the canid ferox specimens that come from Hagerman had that. None of the other Canis ferox specimens from elsewhere in the country had that feature, but the one here from Idaho did, or the ones from Idaho did. And that Canis theodes have it, and so it's from Arizona, and its closely related species from northern Mexico all have that feature. And our one has that feature as well. But if you look at modern coyotes, you look at modern wolves, or even extinct things like dire wolves, they don't have that extension of the blade back towards the talanid. So that means that our canid belongs to sort of a small group of canids. And so here's Canis ferox here. Here's the main group of all those sort of dog-like forms that you're more familiar with, from coyotes to wolves to dire wolves in through here. And this is Canis theodes and its close relatives. So our specimen would belong to this particular clade here, right? Coming off of Canis ferox, because these are the only ones that have this very derived feature. And so again, we would probably be somewhere sort of similar in age to something after Canis ferox, but probably well away from anything that's late Irvingtonian to Rancho-Brooklyn. So maybe something at the end of the block, and like Canis theodes, would put us in this sort of range. Okay. So we would have a very lightweight canid, something like a jackal, compared to a modern coyote or compared to a wolf, based on size of the tooth. All right. Our other carnivores, we don't have a lot. We essentially have half a tooth, which is quite common for some of the teeth we have from freeze-thaw that occurs. It's like things get wet and things get broken sort of long right down the middle. But the individual teeth don't show much for wear, in the sense of, except for wear that the individual put on, these teeth have not been transported much at all. The cusps are generally in good shape. So this upper premolar for a lynx, all those cusps, which are rather delicate, are all still there. The tooth has been essentially broken in half through any kind of crack. Water gets in, it freezes and splits the tooth apart. So we have it in in this upper premolar, we have it in this lower premolar over there. Okay, so all we can say is we've got something that's consistent with the genus Ursus for this lower premolar, and something that's consistent with a lynx, although we can't tell the species because it's not hugely diagnostic. We need some other teeth to help us out trying to decide which lynx we may have. So is it Canadensis? Is it Rufus? So we've got to come to that conclusion. And we just don't have enough information truly to give us any idea. Okay, so we'll come back to those two taxa when we sort of gather all our animals together and what do they tell us. All right, so we've looked at our herbivores, we looked at our carnivores. It's now time to look at our rodents. Okay, so one of the things we've got several teeth of a porcupine. Okay, and so this family is interesting from the fact that it's represented by two genera, one in South America, where porcupines originally have come from, okay? And so that gives us a time frame that this particular genus, Orethizon, our specimens can't be any older than around 2.58 million years when the land bridge in Panama comes up and allows for exchange, the Great American Biotic Interchange between North America and South America. That's when we first start seeing porcupines in North America coming up from South America. Okay, all right. So the South American genus is Sendao, and then the North American genus of porcupines is Orethizon. Okay. But there's something really peculiar about our particular porcupine. It is gigantic. So here's a number of measurements we were able to get specimens of to take a look at. The most complete of the tooth we have is that lower premolar that we have. And so in measuring fossil specimens of the extinct species, that does occur in the local faunas here in Idaho and in central Washington. And the modern taxa and then extinct members of the modern taxa that occur like in Rancho La Brea deposits, that's their size range here. And here is the size range that we have for our particular lower premolar. It's about almost twice the size, or at least another 50% or more. And it doesn't matter what measure for the premolar or the molar we have, our teeth are significantly bigger than anything that we have within the population. So we have a new species of giant porcupine that's not found anyplace else. Again, it would be nice to find a little more material that not to be secure about the size, but to give us a little more for comparison to be able to write this up as a new species and provide a name for it. Okay, so our porcupine is clearly part of the genus Orethizon based on the features that we see in the premolar and molar, but it's a giant one. All right, the next is a beaver, and this was Marlena had done the looked at a lot of the initial information on our beaver, trying to decide which one of several beavers are possibilities that exist in these series of faunas, both on the West Coast and here in Washington or in southwestern Idaho. And from the series of characteristics that she examined, that was clear, no question, we had a half dozen different features that said it was not only in the genus Castor, but in the extinct genus Californicus that's known in a variety of deposits from California up here into Washington and into Idaho. So this fits size-wise, it fits morphological-wise, so we're confident about that particular taxon. All right. And then the last taxon we're going to talk about is our muskrat. And this has been one of the most interesting. And this is where Jonathan had started some of his analysis, and then I have taken over since then. And interesting because this is our most complete specimen. Not only do we have some good teeth, but we've got a good jaw. We've got an in-place incisor. So we have lots of characteristics to go by. And this has been helpful. The problem we faced is as we tried to figure out which one it was some contrasting views on taxonomy by other workers, which indicated some real differences. Most researchers agree that there's two genera of North American muskrats that we have, a real sort of older primitive one, Pleistocene, and then the current genus of muskrat that we have within North America, Undatra. Okay, and so you can see the living one here, there's Undatra, and the living species is Zebethicus. Okay, well, we've got a particular worker that does a lot of work on rodents from Oregon, and he's convinced that really we only have one species, which he thinks is Zebethicus, and then all these fossil species are just sort of subspecies or different populations through time. Okay, and part of his reasoning for that is if you sort of scale their first lower tooth, I'm going to go the other way. This big one here, the largest tooth within the jaw, their first molar, as if you begin to plot out all these different specimens, it has sort of this just continuum of size going from Pleistocene down here, that's from the early Blancan to sort of mid Blancan that we have of Idahoensis, mid to late Blancan in through here, and then Irvingtonian species, Rancho Libraean to modern species in here. We just have this continuum, size continuum. Well, that would be good if the teeth all looked the same, that you could make that kind of argument for. But in fact, the teeth don't look the same. If we go back again, the numbers of triangles here and the number of reentrants is different between these different species. Okay, so there are fewer triangles in the shorter teeth here, and there's fewer reentrances when we look at Pleistocene. It's different again when we look at Odontra Idahoensis, and we only get similar numbers to the modern taxons Zebethicus when we start looking at some of these Irvingtonian species. Okay. So one of the things that we could say is that if we make some comparisons between our taxon here with the little red circle out of Priest River, is that it has a length, a size based on length that's similar to Irvingtonian, matter of fact, to mid to late Irvingtonian taxa. Okay. The only problem is when you combine it with its width, we have a good length, but our teeth are kind of fat. So we have a small length to width ratio. That is, we got something, well, more towards a square than towards an elongate rectangle, although all of these are elongate rectangles, but more squarish. That is, it's for its length, it's fatter being across the tooth. So when we look at the length-width ratio of ours, where it matches up to are these Blancan species back here. It doesn't match up with the Irvingtonian, and it doesn't match up with Zebethicus from Rancho Libraean age or from the modern ones. And so again, when we sort of combine all and look at the data from Blancan taxa compared to these other ones, then from length-width ratio, what we have for ours and all these other Blancan taxa are significantly different in their length-width ratios. That is, they're shorter and wider, mostly being wider than what we have. So if we match up with other Blancan in a number of features, then what we also have is a really big muskrat. Okay. So if we're of the same time frame as some of these, our specimen is bigger. Again, similar to what we had in our porcupine. Okay. Since we have a mandible, we have lots of possibility of characteristics to look at. And so one of the things we're actually able to do because of this specimen, we also have a couple of upper molar teeth combined with it. So a number of characters, we had enough characters that we could actually do a phylogenetic analysis. All right. So here is our tree, sort of our best, shortest tree, sort of based on heuristic analysis, that means the shortest tree is probably our best story, okay? And so this is our shortest tree, and where it puts our particular Priest River species is as a sister taxon to that other Blancan species, Idahoensis, that comes out of the deposits in some of that southwestern Idaho. Okay, so one of the things we do is we try to test our topology, our branch sequence within this. And so even though we have a tree, we want to test how good is this tree? How reliable is this tree? So we do something called bootstrapping, and I'll explain what that process is. So any computer program that runs these phylogenetic analysis starts off by taking the first 4 taxa in your order in your matrix. So whoever you've listed first, and then second, third, and fourth, and their series of characteristics. It takes the first 4 taxa and constructs a tree. And then it picks out the 5th one and sees best where to place it into that tree, giving you the shortest tree possible, or series of trees, okay? And it goes on to the 6th, 7th, 8th, depending on how many taxa you have. And then it produces your shortest tree once it gets to the last one on the list, okay? One way to test that is through this bootstrap analysis, where now you're telling the computer program to select randomly 4 taxa and then randomly add the next till you go through your entire suite of taxa. So there's a large number of combinations that you can have. And so we started with saying, okay, do this process 500 times. Then we went do it 1,000 times, and then 5,000 times, wanting to make sure all the time, to see how often do we get certain combinations of groups together? How reliable are certain portions of our tree? So anytime we get a bootstrap value more than 50% of the time, so think of these percentage of time that this relationship comes about between our Priest River taxon and Odontra idahoensis, is 56% of the time it came up. Okay, 64% puts all of the fossil taxa closer to each other than we are to the modern taxa, and 83% of the time, all of these taxa are grouped together compared to Pliopotomes, our early Blancan taxa, or our outgroup from the same tribe, but from a different sort of grouping heading in a different direction than muskrats. Okay, so this is our outgroup here. All right, so this tells us that our Priest River taxa is most closely related to the Odontra species out of some of those Blancan, Idaho, Hagerman, Grandview type of faunas. Okay, we also tested in one other way, and this is a very older method of testing, but we wanted to try just to make sure, and it's called jackknifing. And it's basically you eliminate a taxon, and how does your tree look? Does it get all screwed up, or does it come out looking like it should, just minus your 1 taxon? And so where we did that for eliminating most of these taxa, did this relationship stay? And it did. And then on those particular trees that we did through jackknifing, we ran bootstrap, and we got good, similar kind of support again, that our Priest River muskrat is most closely related to the Idahoensis species. Okay, and that is a sort of mid to late Blancan. So we would have some other Blancan taxa that we're also closely related to. Okay, so that gave us, again, some other ideas of who and what are we related to. All right, so from all of this, from our 9 animals, we can put in time frames for what we know for particular genera, for some specific species, and what else is known from different places within the country. And it gives us sort of a band of overlap here, okay, for who we have. So we know our muskrat is closest to Idahoensis. We know our giant one have some similarities to the not more to the fossil one than the modern taxa. Here's our beaver. Here's our little cervid Bretzia, our Antelope here. So if we think it's Tautnesis, that's going to pull us older. The horse says we can't be any younger than the end of the Blancan at 1.8. Okay. If we're related to Canis ferox or Canis thyoides, that the dog we have pulls us back in time. And yet the links that we have, links don't come into, there are particular areas within North America till around 2 million years ago. So that's something we can't be any older than, and we can't be any older than around 2.56 million years ago because of when the genus Odontra appears and when porcupines first appear. So our best guess is within this time frame that we have here for the late Blancan, we're probably in the latter half of it, somewhere between 2 million to about 1.8 million years ago. So all of the taxa we have, this is sort of the story that it's telling us. So it's early Pleistocene in here, and where we are within the Blancan is within the late Blancan. And if we use that other designation, this would be within Blancan 5, okay? So given that, so this is where we would place our Priest River taxa, somewhere pretty close to the Grandview one, as far as time. That's a little bit maybe earlier within the late Blancan, and ours may be in the latter half of that. But there's a lot of taxa we share in common with the Grandview fauna, okay? Although we have some of these peculiarities about our particular fauna that being further north is this part of the reason we have some giant rodents, but yet we have small versions. So we've got a small Antelope caprid, pronghorn, and we have a small deer. So something about the environment that we have is a bit unusual, where we get giant rodents, yet small herbivores, okay, with the exclusion of our horse. All right. So what was the environment like? So what we have is this big bank of mud sediments that we have our fossils coming out from. When we look at sort of the areas today around where some of our locations are, and you sort of get a chance to look from above here with Google Maps, one of you see where you see the sort of pathway for the Pend Oreille River is you can still see some old oxbows that are in there. And this would represent more of the environment we would have had. So we would have had some big, thick overbank deposits where the river in its original form before the dam was ever there and before the Ice Age flood came and sort of straightened out the path of the river, we would have had a lot of these particular oxbows in here. Okay, and that's very similar kinds of environments that we see throughout the Ringgold Formation and where we see some of the environments that are around the Snake River. So similar suites of animals and having the kinds of beavers and muskrats that we have. Now we have porcupines in these particular areas. Some of the cervids that we have, the horses we have things that were also parts of these same kind of environments in some of these other locations, and we would have had these environments there in the past as well. Okay, so we believe we have this sort of marsh, oxbow lake kinds of situation where these animals were at the particular time. Okay, all right. To sum up then is, so when we look, we have only two sort of close in time faunas here fairly locally. The closer one here from central Washington to where we are in the Priest River and spans between that and southwest Idaho. These faunas span sort of 47 million to about 1.4. So it takes us from the Pliocene and the beginning of the Blancan land mammal age into the early part of the Irvingtonian, with the youngest we have out of the sequence from southwest Idaho. Okay, so we think we have a late Blancan local fauna from there, and we have many taxa at some level, certainly the generic level, that are in common with some of the ones that are closest in this sort of late Blancan time range. Okay, but it is the first Cenozoic vertebrate site comes from northern Idaho. Nothing else in the Cenozoic of any kind of vertebrates are known from the northern half of the state. Anything that's known has come from localities within the southern half of the state. So this is a sort of new kind of age represented in a new location here in northern Idaho. And we're going to see what we're going to continue to add to this. And we're getting ready to sort of finalize putting together our manuscript with what we have now. We would like to find a few more things so we can maybe possibly in our original paper name some new taxa, but at least we want to put the fauna out there and let it be recognized. And that will be our first paper, with maybe some short papers following up on maybe some of the individual rodents like our muskrat and our porcupine. All right, so that's my part, and I'm ready for questions of one of the other fossils we found from the particular area that turns out to be a bison from one of the localities that we got some specimens, but that locality has been reworked because bison don't occur here in Western North America up to about around 240,000 years ago. So our older fossils have been reworked in this one particular locality we found the bison. All right. So questions?
Yay, of course. Yeah, so since you are talking to a bunch of geologists, when you are looking at this, are most of them kind of reworked, or how are the fossils?
No. Most everything's in place. So the original sites that we had, I took samples out of this clay. I sieved them down, washed them down. There was in-place bone within these particular deposits, well away from some of these things. Because that area gets flooded during portions of the year, we can't work in it. It's times of the year that's non-recreational, sort of winter, early spring, or late fall, when they drop the level of the dam, that we can actually get to some of these localities. So now it's just sort of this big bank of clay that in the past would have been sort of a big terrace. If the original river was down to the level it would have been without the dam at all. Okay. And then we could actually sort of attack, we'd be able to see the full sequence. So we're only seeing sort of the top part of the sequence before it's gotten cut out by other things. So Jonathan's going to show me a site here in a week from Saturday on the other side of the river where the stratigraphy may be more continuous and be able to follow it up section more than we have at this particular part, because we're blocked off by some railroad tracks and other things, so that we're on the flats and we can't see where the sequence goes above that.
Okay. Fascinating. So yeah, if people have questions, you can put them in the Q&A, and we're getting a couple. And being geologist, Andy Buddington's asking if you've ever seen any ash beds in there, maybe like cascades. Not
yet. In that other rework section, there looked like there was some things there. But again, having the bison, that makes that stuff all Rancho La Brea, and that's younger stuff. And it could be as young as sort of 14,000 years ago, that kind of age, or even younger, heading into the Holocene. Unknown. The only good thing is that the other fossils we found from that locality, we also have them from our in-place locality. So we know where they are probably originally came from.
All right. Okay. And on with Andy, just Columbia Basin, we like our old rocks. So we want to point out there's some 2.65 billion year old rocks across the
there's some older ones, and for me, I'm used to working in older rocks as well. Yeah. So right, so our Antarctic stuff is all latest Cretaceous stuff. So yeah, I'm used to working in sort of 70 million year old rocks. So
Very cool. So Jenny Thompson's asking, how did you find these tiny teeth? And did they all die in that same area, or were they?
Yeah, so given the fact that they're not tumbled worn, right? Anywhere we have is just wear from the individual, like one of those deer teeth. That's from an individual that just would have been old and worn its teeth down from use. So these things are in place. Most of the damage we see to these teeth has been caused by freeze thaw, where they've come close to the surface. They've gotten wetted by snow or maybe river water that's come up during the time when they fill the lake up. And then they've got a lot of water content, and then wintertime they get cold and they just fracture. We're not seeing damage from transport. So that's why we think these things are pretty close in place to where they occur, because that's not the kind of wear that we see on the teeth. So even though they're in a close to a lacustrine type environment, they haven't been transported a long way at all. So that's why I think these beds, I wanted to test going a little further back in the bedding plane, digging down, getting some sample, and is that bone in place? And it clearly was. So it's not something that's kind of been glommed on or washed from elsewhere and just stuck at that point as a good point to accumulate bone.
All right. So our own Nigel Davies actually pointed out why I was thinking my cat might have been scared if he was around the Pleistocene because of large muskrats. Oh, these rodents of unusual size. What might cause the variation in these muskrats and porcupines in this location?
Well, it may be just great habitat up here further north. We're not that far north that you can talk about things like Bergman's rule, where animals further north than ones in the south are bigger to put up with colder temperatures. If all the animals were that way, I could make a case that our rodents were. But we've got dwarf pronghorns there, so tiny things, about half the size of a regular pronghorn. And then the deer we have is small like a mule deer, not big like white-tailed deer that we have that you see in the local area, and certainly not anything yet big enough to be in sort of the elk moose category. So we're looking at kind of animals, and clearly it would have been sort of warmer in the early Pleistocene before we start getting into all those glacial sorts of ages that come on a little bit later. So it would have been good habitat. One could suggest that, versus the way central Washington looks now and southern Idaho looks now, they too would have been more lush several million years ago. And so one is that maybe this is just a great spot and these animals sort of got there first, and it's a great habitat before other things have moved in. And they were just able to get that big for lack of competition, say. So all we can conclude right now is that something was good for these particular size of rodents to come in. And these are still early members for those particular groups. So they're new innovations coming into the area. And so conceivably, one of the reasons they were able to get larger, whereas our beaver has sort of been around for a while, right? It's part of a group that's been in Western North America for a while, and its time frame extends a little further back.
So it wouldn't be like your background that you have right now?
Actually, this is younger, as those are dire wolves in there. So that's Rancho La Brea. This is from a recent article that came out that showed dire wolves aren't closely related to wolves at all, from DNA they've been able to get from some of the teeth and some of the skeletons recently. And so dire wolves are no longer in the genus Canis. They're going to get stuck way out on their own.
Amazing.
But it was a cool photo.
Yeah, no, I was kind of mesmerized. I was very happy you made it to the whole top. So yeah, I looked up real quick. It looks like you're about to go in the Illinoisian glacial period there, and it kind of goes in line with this question we had from Dale. What happened about 1.8 million years ago to cause the extinction of 4 of your species?
Probably one of these things that we're starting to get some change, because we do see that in not only here sort of in the Northwest, but other places in the West and Midwest, is you do get this change of fauna that we refer to as the Irvingtonian. We see certain taxa come in. And one of the things that we really begin to see is things starting to dry out, and we're starting to see more grassland. Hence, you get equus in there as sort of the major grazing horse that goes out. One of the now sort of radiation, the carnivores, we're getting all those sort of now dog and wolf kind of coyote looking things out there as well. So we're getting more wide open terrain where being able to run is going to be different. And then we know it's not long before things start getting cold. And then that starts creating fluctuations that we see in some of these different land mammal ages. But if the further south you go, so like the Rancho La Brea talking about Southern California, things are still pretty toasty down there. That's not bad.
Nice. Sounds very good. So the next question here from Mac is, at what age range does fossilization happen to these bones, or are they fossilized?
Yeah, they're really silicified. So just stuff coming through local groundwater, bringing in silica to replace the calcium and phosphate. And so, yeah, these things, you can thunk on them, and you can tell things that Jonathan brought in. You can tell what's fossil versus not fossil just by picking the bone up, the weight, the density there, and you can tell that these things have been silicified, the fossils we have, and they're, like I said, they're in pretty good shape. The detail that we have that stays preserved is really quite good.
So do you have any, just a personal question, do you know about how long that takes that silicification? Can it happen pretty quick? Or, I mean,
given some of the stuff that looks like there's some subfossil stuff he's brought me, this could be like Indian midden stuff. It could be stuff from early, sort of early humans in the area, but there's stuff that's already maybe, sort of anywhere from 10, 11,000 years that clearly has started the process. And the fact we're talking about a couple million years, that clearly within a number of thousands to 100,000 years, that fossilization process has taken place.
Okay, and then Jenny Thompson's got another question. So are there only teeth that you're finding?
Most of what's been teeth, surprisingly, but we do have, in part of it, has been that it's clear we've had some other jaw material, but the bone seems to fracture more than the teeth do. So it's great if we can get some jaw material like we have for a muskrat. And it may be just where we're looking. And so this new site, Jonathan's got another jaw that's come out. And so this may provide something that's where the preservation of more bone is prevalent rather than teeth. But it's not unusual in any kind of deposit where you have mammals that you tend to find more teeth than you do teeth within a jaw.
Very interesting. I was going to say, we actually have one of our members tonight here is Donna, and she gave me some Oligocene bones to share with you, and you kind of put the other bones aside and said teeth. And I remember I just assumed that you just focused on the teeth for classification.
No, well, teeth are the most diagnostic, but usually from jaw and jaw shape, we can get fairly close. But, sort of the teeth are those things that people that work with mammals have most of their characteristics around. Because the variation that occurs, so one, we can tell, what kind of carnivore we may have, what kind of herbivore we may have, where the jaws may look similar, but the teeth have different patterns. So a camel versus a cow, the jaws aren't all that different, but the teeth are very different. So.
It looks like one of our last questions here is going to be, what made you look specifically at the muskrats? Is that just because you had that jawbone?
Yeah, just because we had more material to deal with, that we could generate enough characters and characters that were out in the literature to have enough to make the kind of comparisons. So hopefully with whatever this new specimen is, I know it's a rodent. What I'm hoping it's from the porcupine rather than being from the beaver, because the beavers are pretty well known and have been well described, not only out of our close regional faunas, but elsewhere within the US. But since the porcupines, things are newer, like with the muskrats coming in from other areas, that these are sort of more interesting things to take a look at. So we'll see. I'll let you know. I'll send you an email.
All right. Yeah, I'm looking forward. I hope I can see you in the hall here someday.
Yeah.
So just as I don't see any more questions here, but is there a place that you would like to go to in the future? I mean, if you go up northeast Washington, you can find quite a bit of glacial bar.
Yeah, I mean, it's clear that we do have good areas to look in, and so the area sort of around Hanford and out to Yakima, there's certainly places in there. So I had a good colleague of mine who went to the University of Washington, and he knows a lot of these places, and he's yet to tell me about them. I mean, I've seen fossils, but he hasn't told me where exactly they are, because he still comes out and collects from some of the amateurs that are out there to see if there's anything real new. But now that I've been in Washington here for now close to 15 years, he still hasn't told me where he's getting some of his stuff from, right? So
that seems legitimate. Yeah.
But now, see, I've got a place that say, well, I can take you to this place if you show me where your stuff has come from. So he's in this same sort of Blancan time frame here from Washington. He was well aware of all that stuff, and in fact, he had worked on some of the rodents. So I've consulted with him a bit. So he had been he retired out of the School of Mines, and now he's down associated with University of Louisiana, where Carmen came from University of Louisiana at Lafayette. He's down there now.
Very nice. It looks like we have another question popped up too, though. The ratio of carnivores to herbivores, it seems like 3 carnivores to 6 herbivores. Is that a typical sort of ratio that you would expect?
It seems a little high, because carnivores are just rare. It takes fewer than that. So it's interesting that we have a look at the carnivore community already. There's still some other things that I would expect to find as far as carnivores go, is that all of these other localities, which have really been worked hard through long periods of time, a lot of people going back year after year, a lot of students, professors and things revisiting all these kinds of places. They've pulled out literally have faunal lists of 25 to 35 taxa. And one of the things that many of these sites have is some kind of saber tooth there. So that would be something we would expect to see as well. We should see things like sort of llama-like camels. Those kinds of things should be there. We might get some kind of mastodon out of the area. So we're too early for mammoths, but mastodons could be there. So a variety of other things, certainly a variety of other kinds of herbivores should be there. Again, we've only been looking for around a year now. And if we now get some better weather, we can spend some more time up there. It would be, especially getting some sites that don't get flooded during the summer, where we could spend some time up there, then we could even enhance our fauna more. But the fact that we've got a reasonable suite of some rodents, some ungulates, and some carnivores indicates that we probably have a more extensive fauna if we can work it a bit harder than we've been able to do.
That sounds good. Great. I mean, and we just had another comment from actually from your alumni at Riverside there, Ann Johnson mentioned you could make in 3D models of some of the bones, I'm guessing, or the teeth might be done. We just actually talked to Ann today about some amazing stuff they have going on. And I know our paleontologist, Lindsay, has a nice little 3D scanner too. So in the future.
Yeah. So especially something that we have, like the muskrat, some of the beavers, some of the porcupine things, doing some casting. And then, well, these days, a lot of everything's done by 3D scanning now. You don't even have to make any kind of mold around the tooth or jaw anymore. You just scan it and do 3D printing to make some reasonable replicas. So new technologies making some things easier.
There we go. Well, thank you very much, Judd. That was awesome. That was amazing. I hope we can get you back another time after I get maybe a status update in a year or two here in person.
Yeah, absolutely. Sounds great.
Yeah. Okay. Thank you, and have a great night.
Okay. Thanks, all of you. Thanks for listening.